Hello everyone, welcome to the panel, The DeepTech Effect in Manufacturing. And we have with us Mr. Bernard Wolf, Professor of Advanced Manufacturing, Deakin University, Mr. Prajakt Raut, Managing Partner, Supply Chain Labs, Mr. Manish Jha, CIO of Addverb Technologies, and Mr. S.P. Arya, Director and Managing Partner, BizTek Advisors. Welcome, gentlemen. Prajakt, glad to
Thank you
have
very
you
much.
on board for the panel. And if you could start
Thank
off
you.
by telling us about the role of deep tech in supply chain management.
Yeah. So manufacturing technology has always been very, very important, right? Deep tech is only an advanced area of technology where there's a lot of research, science, etc., that goes into enhancing the value of technology that already was in use. Now, traditionally, what was the role of technology or what were the priorities of the manufacturing sector? Better product, faster time to market, lower cost, employee safety, and all those other things. But what's happened after the pandemic is that the most corporations have put the agenda of making their supply chains a lot more resilient. What that means is how do you prevent disruptions because of things like a pandemic or any other circumstances or geopolitical issues like China factor and so on and so forth. As a result of which, the kind of technologies that companies need to have now requires a much better synchronization between multiple stakeholders than the siloed environment that they were operating in. And that, in my view, is the single biggest factor that is changing the way industries, including manufacturing companies in the manufacturing sector, are looking at deploying technology.
Thank you, Prajakt. If you could give some examples into how deep tech has enabled
Yeah,
manufacturing
so if you,
industries. So once again, let me complete the question.
yeah,
Uh, Thank you, Prajakt. If you could give us an example of how deep tech has helped manufacturing sector uh, come up with solutions for business continuity in the post-pandemic era.
yeah, sure, Vaishnavi. So if you think about it, linking it back to my earlier point about synchronization between multiple stakeholders, which has become a lot more important in today's environment. So think of the newer technologies that companies are adopting, IoT, 3D, blockchain, AI, etc. Now, while deploying each of these technologies certainly enhances the value of what they would be able to, what companies would be able to get with the use cases built on those technologies. Using a combination of some of these technologies actually exponentially enhances the value of the thing. Let me illustrate with one or two examples that would be relevant, say, for example, in the manufacturing setup. Think about IoT. Now, IoT is used a lot for, say, for example, predictive maintenance. But when it comes to predictive maintenance, if you are now able to layer that which technologies or say, for example, blockchain layer, which authenticates all the other participants that would need to be in that entire environment or that ecosystem of that enterprise, so that, say, for example, a predictive maintenance needs to be triggered, who are the other parties that need to be informed, and what is the chain of command, what is the chain of sort of automation that needs to be triggered as a result of that. So it's use case specific things that companies will do. Previously, automation was largely from a point of view of optimizing, say, for example, the internal production processes and stuff like that. Now, this whole optimization has been taken to a slightly wider level. Again, to illustrate with an example, earlier, say, for example, procurement and, say, for example, ERP systems were about automating the existing processes so that there could be operational efficiencies in the procurement. Now, with a lot of analytics, a lot of AI that is being used into the system, it is now providing the kind of insights to organizations that were previously not possible. Now, without AI, for example, analytics, etc., throws up insights using which some of the people in the organization would have been able to build strategies that will help the organization improve. But now, when you layer that with AI, what it does, instead of people telling the system what it needs to do, the system can actually guide the organization in what would be the most optimal way. And in many cases, they are able to, on the basis of large amounts of data, etc., which would otherwise not be possible for humans to ingest and to be able to infer insights from, it makes these kinds of circumstances possible. So the net point that I'm making is that synchronization between multiple stakeholders and layering multiple technologies to be able to create use specific special interventions is what is or use case specific interventions in the context of every organization is where the most use of technology would be. What is also happening, Vaishnavi, is that a lot more organizations are now building more nimble solutions on top of their existing automation systems and their ERP solutions. And that's where a lot of the supply chain startups come in. They build use cases and solutions which are nimble, agile, cloud-based, use case specific, and very specific what should I say, value propositions that reside within the ERP or on top of the ERP, thus making the organization's entire automations platform a lot more resilient, a lot more nimble, and a lot more flexible in current environment.
Got it. Got it. Thank you, Prajakt. We have with us Mr. S.P. Arya, Director and Managing Partner, BizTek Advisors. Welcome, Mr. Arya. Welcome to the panel.
Thank you. And namaskar.
Mr. Arya, if you could throw some light on the role of deep tech in shop floor transformation.
I think deep tech is not a new thing for me. I have been in industry, especially in IT, ever since 1983. And we have been using a lot of solutions which were helping us in completing shop floor work or tasks quickly. But of late, with the advent of latest technologies like artificial intelligence, which has having its second wave after in 60s, it was quite a buzz to talk about. But recently, in last 6-7 years, it has taken off like anything. And blockchain, nanotechnology, okay, and then IIoTs and all those kind of technologies are coming up, catching up fast, and giving a lot of solutions, okay, in convergence with each other. When we talk about deep technology, it certainly necessarily has to be a convergence of 2-3 technologies. Okay, maybe AI is with some physical product, okay, and deep learning and some IoT technology, then combined with the AI and cloud and quantum computing and all these things when put together and give you a solution which can solve a typical, very complex problem in shop floor managing and manufacturing organization. This is what deep tech is all about, and deep tech is catching up very fast, frankly speaking. But I think it will take quantum leap from here. It has already taken within 5 years. It has taken at least the 3-fold, 5-fold. It has can say jumped to this spread its can say its wings around the industry. It will go into the trillions of dollars in time to come, and its role cannot be ignored by the researchers, by the scientists, by the engineers, by the entrepreneurs, by the government, and by you can say the academia. So these all have to join their heads and work on it, and then bring in deep tech solutions concept to speed up the concept manufacturing concept management and shop floor management in a way that it produces at a very high efficiency and effectiveness.
Now, how will the manufacturing industry then transition in a post-pandemic era where business continuity is one of the prominent aspects for businesses to focus on, and how deep tech will play a part in it?
See, if you see, most of the manufacturing requires, okay, it's unlike IT industry where you can sit at home and work for your say industry. Manufacturing requires presence of the people on the shop floor. And under the pandemic, which was the really difficult, and that's why it hurted the most the manufacturing industry. Okay, so more and more solutions are being targeted to do the work with a very less of the concept manpower, human resources, and that's the only way actually. But yes, somewhere this post-pandemic scenario and during pandemic scenario has forced organization to automate higher and higher, and almost at each stage of the manufacturing steps, they are automating the things, bringing the solutions which are giving them high outputs with less manpower. So this somewhere will had jobs hit the jobs employability of the human resources. But somehow, if more and more pandemics, the way these are coming up, new variants are coming up, whether it's Delta variant or Omicron variant, they are forcing organization to take those kind of stiff or tough measures to automate their shop floors and keep human resource safe from this kind of impact. But yes, definitely, when such things will happen, jobs will be created somewhere else also. So yes, we have to create a balance, not to affect the jobs too much, and yes, still achieving our post-pandemic challenges in a shop floor effectively without losing much of the outputs and product outputs and quality as well.
And thank you for taking time out and being with us on this panel. Thank you.
Thank you very much. Thank you.
So yes, hey everyone. So I'm Manish and CIO of the company, and I take care of the software development and robotics in Addverb. So what we are here actually, the one of the product we are building is the manufacturing education system, which actually controls the planning and the manufacturing of our software. So the challenges we are having in the manufacturing are the related to planning, the predictability of the manufacturing, like how much time it will take, and also the ensuring of the quality of the product what we are delivering. So we are getting means the way we are growing, our manufacturing has to meet those challenges, and we have to deliver the things we have to deliver the product in a predictable amount of time. So in our manufacturing education system, we applied a DeepTech. So we analyze the data, and then using our technology and in software, we are actually optimizing the resources. Resources can be the machine, resources can be the human being. Also, using our analysis and using our software, we know when to check and where to check where to do the quality check. We also control the quality of the product. It means like we, based on the data, we analyze that using software, we analyze that which of our resources are efficient and which of our resources are non-performing. And based on that, our team works on those resources. It could be machine, manufacturing machine, or it could be human resource as well. We are also applying a deep tech in a supply chain and the material movement inside the warehouse. When we know okay, so this is using our deep tech, we know that how much time each steps of the manufacturing will take, and based on that we ensure that our supply chain team ensure that for the subsequent steps when how to plan the material. So this is how we are applying the deep tech in manufacturing.
Got it, Manish. Thank you. When pandemic hit, businesses had to be stopped, and then the question arose for manufacturing sector about business continuity. How can deep tech then play a role in the business continuity?
Yes, so this is actually a very good question. And in fact, in during the second wave of the COVID, we were also affected with the same. But because of our technology and because of our software, we could able to trace. Means we have one very good feature. Means using the deep tech, we have the predictive in manufacturing, and also the people sitting outside outside of factory knows what is the status, and they also predict the output of the factory using the doing some analysis on the data like work in progress or traceability. Those features we are having our in manufacturing education system, which helps our high management and the higher management and the supply chain team to predict the data without without coming to the office. And so this is how means in the during the second wave during the second wave, when most of the people were affected and very less people were available, we could able to control the manufacturing and also get the output out of that.
Sure, Manish. Thank you. Thank you for those insights.
Welcome, everyone. My name is Professor Bernard Rolfe from Deakin University in Australia. I'm a Professor of Advanced Manufacturing and also Interim CEO of Regional Advanced Manufacturing Cooperative Research Centre, BID, bringing together a cooperative of new and young regional and rural startup businesses seeking to find innovation pathways. Today, I'm going to talk to you about additive manufacturing and how it is a powerful assist for regional and rural Industry 4, primarily going through Industry 4 and its advantages and how it couples with additive manufacturing, but then bringing in that rural and regional aspects. First of all, I should acknowledge my collaborators, Professor Ian Gibson from University of Twente, who heads up one of the Fraunhofer institutes. They're based in Twente on additive manufacturing, amongst other things. Professor Martin Leary from RMIT, who's a professor of design and additive, and Dr. Maya Khorasani, who helped me put this presentation together. Now, just to give you a bit of perspective on Industry 4, I thought we'd go through some background which will help us understand the rural and regional context. Now, with Industry 4, it's one of the industrial revolutions, and commonly we think of Industry 1 being the first industrial revolution happening around 1760, where we see that transition from animal and human muscle into out of into steam power and getting into the early stages of automation. Then Industry 2, what we're seeing is that acceleration starting around 1870, where we're starting the formation of electricity grids, the formation of production lines, large mass scale transport with railroads, and communication through telephones and radio. Industry 3 is commonly thought of as happening in around the 1970 era, where we're starting to see the impact of computers. So we're starting to see how computers are changing things with the, say, numerically controlled production, things like CNC machines, looking at logistics, which was again transformed by having computers doing a lot of the calculations, finding better quality, better performance, and also reductions in lead times and costs. Now, what we think of Industry 4 is this big transition to mass production, but also customization, where we're able to take on a lot more information that happens in production, but also information that happens at the product line. So a much more, a greater use of sensors, automation, and artificial intelligence. The sensors are usually classified by Industrial Internet of Things, so IoT. Now, coupling that with coupling the industrial revolutions with more agricultural side, because they go together. And commonly we think of agriculture, or the first agricultural revolution is humans going into agriculture and farming, approximately probably 10,000 years ago. Now the sort of iteration from that, it's not quite classified as the second agricultural revolution, but it's the iteration of the first farming is what we're seeing, the new crops and the techniques which have spread out of the Middle East. But historians tend to think of is the second agricultural revolution is the one that started in Britain, where we started to see a transformation of productivity in agriculture, so that the urbanization to support that industrial revolution that was happening, those people could be fed, and that coupling of being able to provide both the food to then also provide the productivity in the industrial space went hand in hand together. And we talk about the third agricultural revolution happening in sort of from the 30s through to the 60s, where we start to see a huge increase in agricultural production and productivity. We're getting to see a real development in terms of the varieties of current crops, making sure that they're very productive. And we see large changes in the productivity in particularly the developing world and its agricultural production. For example, India, which brought in the IR8 rice strain, was able to vastly increase its productivity in terms of rice production, and now India is actually a rice exporter. So a huge change. The change that we're really interested in from an Industry 4 perspective is this rural regional populations, which have been steadily declining relative to large urban centres. So urbanisation across the world has been massive, and it continues on. And so that has implications in terms of manufacturing and ability to be able to do things. So getting on to additive manufacturing as a powerful assist for rural and regional Industry 4, we've got some main objectives. So what we will want to look at is that synergy between Industry 4 and additive manufacturing, and we'll have a deep discussion of this, the data that's needed in manufacturing systems to have an Industry 4 system, and how that can be a benefit in terms of developing such a system in a rural regional area. We'll also look at the potential effects of additive manufacturing in Industry 4, and how digitalization, data transfer, tagging technology, and information can be assisted by additive manufacturing into Industry 4. We'll also look at how Industry 4 and additive manufacturing can reshape the future of manufacturing, and we can discuss, we will discuss some of the challenges that involve. Now, looking at creating, if we look at Industry 4, we have what we have is this loop, which allows us to ensure that our production and our products are suitable for for the customer. It relies on us having access to on-demand and accessible information. That's a critical part of Industry 4. And it's this loop where we collect data from the user, we filter that data, improve our product, improve our production, and really customize our product and customize our production based on all this information we can gather from the product in use, really driving our design. So at the core of Industry 4 is this ability to be able to capture information real time, on demand, be able to use that and drive our designs. So that actual customer usage is incredibly important, the key part of Industry 4. It also allows us to look at sustainability, how we can recover, reuse, repurpose, and recycle products, their materials, because we have an understanding of how those products are used within the economy. So looking at the data itself, critical thing is the data transfer. That data transfer means that we will have a whole range of different data formats, data protocols of how things are communicated. We'll have lots of different sensors which will communicate data. That data will need to be collected, classified, filtered, stored, interpreted, and sent to the appropriate engineers, designers, and production technicians. So with that, we need to make sure our sensors, our industrial Internet of Things, are part of these cyber physical systems, that they are integrated into the products and into the production lines, so we can capture all that information. It'll allow us to have on-demand information to help us continuously improve our products and our production lines. Now, one of the key challenges is how to keep this data secure and reliable. So cybersecurity will be a critical component of Industry 4 as we go forward. We're seeing a lot of this happen on vehicles in the automotive space as we go increasingly towards autonomous vehicles. We're going to capture so much more data about how the vehicle is performing, how our driving performance is continuing, how our car is interacting with the other vehicles on the road, how our car is interacting with the infrastructure. So all these things will be captured. We need to make sure we do that in a quick way. It's not affected by any security leakages. We also need to think about privacy and other things. The products themselves will need to have ways of tracking those information. So tagging technology is a critical part of Industry 4. And in that, we need to be able to identify which part of the product it is, where it is. We need to be able to certify that it is this sensor over other sensors that we're actually gathering information from. And we need to integrate and embed those sensors into products. So increasingly, we'll see things like additive manufacturing being able to directly embed or print sensors tags into products, and also into production lines and tools. So if we think about our tagging technology, we need to make sure we have we take care of security so that the information is not shared with the wrong sort of people. We need to make sure that it's difficult for that information to be counterfeit, or we can correctly, reliably get the right information out of our sensors. We will use this to help our product refinements and make that much more automated, and build into our design, and then also into our sustainability aspects of the product. The exciting thing about these sensors is that it allows us to actually have actual customer usage information. So we can look at habits, we can look at frustrations, we can look at ways that we can customize our product to the user. And we will be able to make things a bit more sustainable, because we'll be able to understand what is our product look like at its end of life. How can we better reuse or repurpose or even recycle that product? So with that, an example is looking at chips within a wheel. We can have those chips embedded into the fabric of the tire, and those chips can give us an understanding of how that product is being used. We're also seeing power systems being put into these systems, where the deflection and the motion of the sensor is building up or regenerating the power used, so that we can have our sensors last longer. And we're seeing that additive manufacturing allows us to integrate and embed our sensors in places that traditionally we wouldn't be able to put our sensors. We're also seeing on the production side that traditionally, we would manually set up production lines, but now we can actually locally and also remotely set up lines, particularly as we get this increase in the computer side of production. So the next step from like CNCs is having a huge amount of both, I guess, design and computer control over production line setup, and also production lines themselves. Means that we can have better M2M or machine-to-machine transfer, because we have much more data, which is backing up how those machines will produce and how they can transfer their product from one machine to the next. And we can get much more actual data of how our production is actually occurring, so we can customize our maintenance and our downtime. What this has led to is what we call, I guess, much more machine learning or artificial intelligence within an Industry 4 setup, where we're using all that data obtained from our industrial Internet of Things and our designs to drive a lot of increased quality, reliability, and thought into both production and to design improvement. It also allows, with the machine learning and artificial intelligence, we're allowed to do learning on a continual basis. We're able to learn quicker. We're able to understand trends and, I guess, features within the data a lot faster than we have in the past. So that gives us a context of Industry 4 and the data requirements, and then how the data is pushing the production and also design for the customer. The great thing, I guess, how additive manufacturing also couples with Industry 4 is what we call mass customization. Now, with all that data we obtain from the usage of our product, we can then customize our design, or what we call personalize our design, so that each person can have their product set up for them. Traditionally, I guess with commonplace manufacturing or established manufacturing techniques, we've not been able to achieve that mass personalization or customization, because basically you have to have one design. You may upgrade it, but that one design then gets produced. The mass customization is the ability to be able to change features on the product within that manufacturing process. Additive manufacturing allows us to do that because we can nest lots of parts in a single build, but each of those parts, because of the use of computer-aided design to nest the parts and do the 3D prints, we can customize each of those parts within the build to our customer. So this is where this idea of mass customization, where we couple additive manufacturing, comes in. So we can see on the left here, we can grade our product so that it can allow for lightweighting, but also load, and that load could change, so we could have different densities based on what the application was for a particular customer, and we can change that within the print. Another, I guess, advantage of additive manufacturing is the ability to have complex structures. So we can lightweight in very different ways. So we can have build structures that were not possible using established manufacturing techniques. So using a customer knowledge, our data that we've got from usage, we can apply that and use techniques like topology optimization to lightweight and customize our product to the particular use that the customer may need. We can see things where we've got complex heat exchangers set up specifically for single or specific use, like what we see with Conflux there, who are on a small setup, a small innovative company which is currently on the Deakin campus. We can also see that we can not only use additive manufacturing for the product itself, but also for the tooling to create product. So we can have complex conformal cooling in the tooling, which allows us to make products faster, allow us to have products that may be much more complex than was possible when we had only used established manufacturing techniques. And of course, all this is using the necessary industrial Internet of Things within that optimization. So the great thing about additive manufacturing is we can embed our sensor, our industrial Internet of Things within each product. We can, by doing so, we can bring our consumer or our customer into the design process, into the development of production, into sort of looking at the supply chain and maintenance, because we have that large amount of data which allows us to optimize every aspect of our design and production system. We will also therefore see significant reductions in terms of manufacturing costs and waste, because everything will be developed towards a customer benefit and usage. And we also see reductions in terms of like lead times and those things, because we'll be have so much more knowledge about how our product is actually being used. So if we looked into the future and this coupling between Industry 4 and additive manufacturing, what we will see is things like visual knowledge, which is going to be really a huge thing where we can start to see prototypes, printers from our 3D printers being much more used in terms of also mixing with our virtual representations of those prototypes. So that rapid production that additive manufacturing allows, coupling with the virtual system, is going to be a huge thing that will go into the future, which allow us to rapidly develop products. We also see in terms of production and planning control, because we'll have a huge amount of data, additive manufacturing allows us a huge amount of flexibility in terms of how we print, when we print. We should be able to see huge improvements in how in our production systems, energy used for producing parts, etc. And we'll also see things like virtual planning, so bringing in our enterprise and resource planning, so ERP systems, which can really bring together our production, or like additive manufacturing, our automation systems, our material procurement, etc. So there's going to be this Industry 4 and this coupling with additive manufacturing may allow us to do a large amount of efficiency and optimization in a broad scale in terms of being a manufacturing or a production type company. We'll also see that within our batch production, as I was saying before, we can customize using additive manufacturing, because within our batch we can actually customize each of the parts. So even though we're producing individual parts, they're being done in a batch in a large scale manufacturing print, but we can customize each one for the customer. We can also use Industry 4 in terms of improving our additive manufacturing processes by getting real-time monitoring of our our 3D prints, and this will allow us in the future to really improve the additive manufacturing process. And we can see that we'll be able to really radically improve products and customize for best usage. So things like this turbine blade, which can have internal structures which aren't possible using established manufacturing techniques. So if we think about additive manufacturing in Industry 4, you can see that there's going to be a huge amount of data because of Industry 4, the embedding of sensors, the tracking of how a product is used, the personalizing of that data, the filtering of that data, the security of that data is going to be a huge thing for the future. And so we'll have to have these large cloud storage systems, etc., the ability for us to then access CAD and FEA from all different places, and to be able to maybe print in many different places, so that we can have closer connection to our customer. So what this means for, I guess, a rural and regional context is that we'll be able to, because we have because of urbanization, we have a smaller workforce available in rural regional areas. But those rural regional areas can have local production, because we're going to rely on cloud systems. They can have things so we can access software on demand services. So we see that this mix of additive manufacturing and Industry 4 is an incredible opportunity for regional areas. We've also seen with COVID that there's a need for sovereign manufacturing, and how, whether it be Australia or India, that that COVID, with the supply chain disruptions, that a lot more local production is needed to ensure we have proper supply chains. The other thing is that I guess capital around the world is now looking for higher returns because of the long period of low global interest rates. So this mix of additive manufacturing and Industry 4 offers a pathway for innovative small companies in rural and regional areas, where they want to be able to produce parts, produce them customized for their clients. Their clients can be based all around the world. But these companies will be able to move fast and be able to customize quickly. I guess the challenge that we foresee for these small rural and regional companies is making sure that they can get the skills to ensure that they can get the ability to drive the additive manufacturing production, the personalized computer-aided design software, etc. But it doesn't need a large amount of people, but it just needs skilled people, and so that's going to be the major challenge for rural regional areas going forward. But it's an exciting future, and we can see a lot of opportunities here for additive manufacturing mixing in with Industry 4.